Great. Okay, thank you very much for the introduction. I guess I'm the first speaker of your seminar series, and that's always maybe a little bit scary and exciting at the same time. So, as introduced, I am the Acting Water Quality Division Administrator. We've had some switch up because our director left, and it causes kind of a domino effect, and so I'm in charge of the Water Quality Division right now. First thing I wanted to do is with this kind of general groundwater-ish irrigation slide is to talk just a tiny bit about me. And you'd think, well, she works for the Mass Department of Environmental Quality. Obviously, she cares about groundwater a lot. I not only care about groundwater, but I care about Nebraska. I'm very passionate about Nebraska. Nebraska I've lived many places in the U.S., and Nebraska is the best. Not only the groundwater and the environment, but the people, the folks, everybody that manages to help take care of the state and lives there and works, and all of you and the people coming in to learn, and agriculture and industry and the economy and the whole bit. I'm for it. I'm just a positive Nebraska person, and I want to show you how groundwater is important to that, and how groundwater quality is actually a big part in all of Nebraska. If you're from Nebraska, you may or may not know this. If you're not from Nebraska, there's no way you're going to remember the little factoids. And it's not really important except to say that we are a pretty good sized state in area, with being the 16th largest state. And in population, not so much. As kind of a side fact, there's a wastewater plant in the Washington, D.C. metropolitan area that actually treats wastewater from about the same number of people as live in the whole state of Nebraska, about 1.7, 1.8 million people, one wastewater plant. So we don't have those kind of problems. But spread out wise, it sometimes makes us more of problems for us. I'm going to talk about drinking water first, and the first thing I'm going to talk about is rural drinking water. Almost all of the Nebraskans that are not living in a town are relying on groundwater as their source of drinking water. And that's about 200,000. I may be off a little bit about that but that's about 200,000 people. They all have their own private drinking water wells, a domestic well it might be called. But so it's really important that we know a little bit about the threats to that. And I'm going to spend the next few slides talking about threats to private drinking water wells. But any of these slides that I show you, the next several slides, it's not just private drinking water that can be impacted by some of these things. It could be public drinking water or just the groundwater quality in general. So keep that in mind. Each one of the titles says threats to private drinking water wells, but this is really about any groundwater situation. On this particular one, it's kind of cool because it's all sorts of things all wrapped up into one slide. We've got a well right down here. And the people who gave me this slide said, yes, that was a well. Well, it's improperly constructed or completed. It may be an illegal well. It ought to be abandoned. It ought to be filled with concrete right now. The location of it is not very good either. It's only about 10 or 15 feet away from fuel storage. So it doesn't take much of an imagination to see what the potential threat to groundwater is with that location and that lack of construction or seal. Septic tanks, on-site wastewater systems, they're also called septic systems, are not necessarily a threat to groundwater quality, but they can be. Let's assume that something goes wrong, the septic system may fail, but may be placed improperly. There may be an improper placement of the well in comparison to the septic system. So there's a possibility that septic systems that are old or failing could be a threat to private or even public drinking water. Other threats to any kind of groundwater or even surface water is large storage of large amounts of chemicals. Flood comes along, lightning, a rail car goes crazy and crashes into that. You have a lot of chemicals that are going not where they're supposed to be. So things like that we don't necessarily think about, but they are out there and they're threats to groundwater quality. Livestock. Livestock can be a threat to groundwater and surface water quality. We have regulations. The DEQ has regulations for agriculture, specifically livestock, for the livestock lagoons. The wastewater drains off into lagoons. They have to be the lagoons themselves have to be properly constructed. We have monitoring wells at a lot of them. And when there is use of that wastewater from from the lagoons out onto the fields. It's spread as fertilizer. That has to be done at agronomic rates, so that we want to make sure that we're doing everything we can to try and prevent that from either running off or leaching into the groundwater or causing a problem to the groundwater quality. Go, go, go. Well, now it's not going. There. And I mentioned that there's monitoring wells at many of the livestock operations. This is just an example of one. And when we're looking at the results or the analyses data from a monitoring well that's near a livestock facility, we have to also try and figure out, is any kind of impact to that well quality from the livestock operation, or is it actually maybe the fertilizer, the commercial fertilizer that was applied to the cornfield too? So those are the kinds of things that we have to take into account. Other threats to groundwater quality might be a big industry, and maybe an ethanol plant or something like that, but also even something as easy as a big truck crash. They may have been hauling chemicals, or just the fuel that they carry on the truck itself, just to make the truck run, can spill in onto the ground, run off into groundwater, or run off into surface water, or may soak into groundwater. One of the big ones I'm going to talk a little bit more about later is agriculture. And agriculture, for what I'm going to mostly talk about, which is nitrates, is one of the biggest threats to groundwater quality. So I am going to spend a little bit of time more on that. How do you manage that? How do you let people have jobs on the farm, have the farm economy, the ag industries that are out there, and yet still try and be as safe as possible to surface water and groundwater? Now, one of the things that we really do have going for us is well construction regulations. Believe it or not, not every state has well construction regulations or driller water well drilling licensing. And that really makes a big difference. Nebraska has, and Health and Human Services is the one that regulates this and has it in their regs. We have construction standards for water wells. So there's a certain grouting requirements for the top of the well to keep things from surface water running off into the well. There's construction standards on setback distances between potential threats, potential contaminant sources, and things like that. And in addition, the folks out there drilling those wells have to be licensed, and the people who are sampling the wells have to be certified. So if I go out and I break the seal of a monitoring well or a water well, not turn on the faucet, but actually break the seal of the well, I have to be certified by Health and Human Services to be a water well monitoring technician, I think it is. And I have that certification. There's testing, there's continuing education, there's all that stuff that goes with that. So not all states have that. I think we are very fortunate, and actually maybe fortune isn't part of it, maybe it's smart. Maybe we're very smart to have that. I'm going to talk a little bit about public water supplies now because of all the population of Nebraska, about 88% of the population uses public water supply, meaning the town has wells and they supply the water through a distribution system. And again, this is Health and Human Services has rules and regulations that manage that. I hope you can see this, the colors and stuff on this map. I think this is one of the coolest maps. So blue dots are groundwater-based public water supply systems. Red dots are surface water systems. Now, how many red dots do you see? Not a whole lot, right? Omaha, Blair, Cedar Knox Rural Water District, which is up at Lewis and Clark Lake. They have an intake on the lake. Omaha has intake on the Missouri River. There's Beaver Lake a little bit south of Omaha, and then Chadron has one lake that they use as a public water supply. There's a few others, but there's just not a whole lot of them. There's not a lot of surface water use in Nebraska, and that's nationally, that's pretty unusual. The gold or brownish color are groundwater under the influence wells. And what does that mean? Well, a public water supply well is located close to surface water, or it's really shallow, and therefore it's considered under the influence of surface water. And for drinking water purposes, essentially that's considered surface water. So they have to do a lot more treatment than you do with the groundwater source. But the size of the dot is kind of indicative of the population too. So we've got a lot of things mixed together. It's kind of a complicated map, but it's kind of cool. So, public water supplies in Nebraska. There's about 530 or so of them. And again, remember, this is managed by Health and Human Services. Of all those number of systems, 98% are groundwater based. So the vast majority of the drinking water systems rely on groundwater in Nebraska. Here's some national statistics. This is just a little bit of comparison. Population-wise, 29% of the population of the U.S., and this we're only talking about the ones on community water systems, 29% rely on groundwater, whereas it's 77% of the systems. Now, why is there that difference? Well, the ones that are relying on groundwater are mostly very small systems. So there's a lot of them, but they aren't necessarily groundwater, or they aren't surface water based, they're groundwater based. I want to show you the same sort of statistics compared to Nebraska. Remember we talked a little bit ago, 98% of Nebraska systems are groundwater based. Well, only 77% nationally. Then population-wise, this number is from Health and Human Services, 62% for community water supply systems. When we talk about the whole state, generally, at DEQ anyway, we talk about between 80 and 85% of the whole state is relying on groundwater for their drinking water. That includes those folks with their private wells, and it also includes splitting up Omaha maybe a little bit differently. Yes, they have the intake on the Missouri River, but they've got 2 well fields too. So we consider that as kind of 1/3, 2/3, but not everybody does that way. That's the way we kind of usually talk about it. Irrigation. Irrigation's a big deal in Nebraska. I don't know if you've ever noticed that. 9 million acres in Nebraska is irrigated acres. That's actually a big amount. Of that irrigation, 93% of it is from a groundwater source. So easy enough to do groundwater irrigation in Nebraska, and so people have taken advantage of that. The surface water canals and surface water delivery systems are mainly in the southwest part of the state. There's a few in the central, a little bit more in the central part of the state, but basically we're talking about the vast majority of irrigation in Nebraska being groundwater from a groundwater source. And to kind of show that, here's a density of irrigation wells, and this is relatively current. You may not be able to read the values real well, but I'll kind of point them out. The darkest brown, pretty much in Merritt County, right in here, is greater than 16 wells per square mile. So 1 square mile with more than 16 wells in it. And that's not just wells, that's irrigation wells. So we're talking about a lot of irrigation, especially in this area right in here. The gold color being 8 to 16 wells per square mile. And then the blue, which you see a lot in York, Seward, and the upper Big Blue NRD area, that's 4 to 8 wells per section. Now, why are there so many wells, especially in that area? Well, back in the day, 40 or so years ago, when people were really starting to get into irrigation, look and say, look, it's not raining enough. Oh, there's groundwater, let's use that. It was cheaper to put in a new well than it was to buy more pipe to stretch it between your fields. So people would put in another well. That's just basically what it comes down to. It was economics. A lot of what we do is economics, and it was same thing for farmers. It was easier to put in a well than it would be to buy pipe. So that's what we have to deal with. There's a lot of irrigation and a lot of farmland that's being irrigated. Let's get this to go. Now, where does all that groundwater coming from? Well, I've got this slide on here. It's from a USGS publication. It shows not only the Ogallala, but the High Plains Aquifer. There's a lot of folks that see this outline up here in Nebraska and say, oh yeah, there's the Ogallala. Actually, the Ogallala is a formation within the High Plains Aquifer, and I'm trying to show that. We're trying to make more of a deal about that, because especially a couple years ago when our folks were involved at DEQ with the pipeline, the Keystone Pipeline stuff, everybody said, oh, it's going through the Ogallala. Well, not everywhere. Ogallala is the gold, kind of the gold-brown colored stuff, but the High Plains Aquifer is a very important part of the whole groundwater system in Nebraska. So don't let people, somebody from Hastings, for example, tell you that they're using the Ogallala. They're not. They're using the High Plains Aquifer. There is a distinction. Most of what you see, though, going all the way down to Texas, is Ogallala. And everybody says, oh, well, Nebraska's, it's all being drained to Texas. It doesn't quite work that way either. It's not the way groundwater works. Hopefully you all know that. There's a lot of dissection. There's a lot of disconnection. Rivers go through. There's breaks in the geology. It's not a continuous one big sheet of sand or something. It is pretty distinct areas. Added to that is the fact that groundwater really doesn't move very fast. In the Platte Valley, and not in the high plains, not in the Ogallala, but in the Platte Valley, groundwater might be going at 1 to 2 feet per day. That would be pretty fast groundwater. There might be some a little bit faster, but that's pretty fast groundwater for Nebraska. On the average side, that's pretty fast groundwater. Slow groundwater, like up in northwest part of the state, maybe in the southwest part of the state, we might be talking about only a foot per day. Or not a day, sorry, a foot per year. 1 foot per year is quite a bit slower than 1 or 2 feet per day. So there's a vast change, a vast difference between alluvial Platte Valley sediments and then something else that's outside, maybe in the uplands or something like that. So I show you that. Let's get this. Evidently when I don't move the slides fast enough, there we go. Where is that groundwater? It's not in an underground river and lake. Hopefully you all know that. It is between the particles of sand and the particles of gravel, or in the cracks and crevices of rocks. If I had brought along a jar and I had it filled with marbles and we poured water on top of that, this is just real basic stuff, you all know this, but the water going between the marbles would actually be representative of groundwater. Not some sort of big tube or something going through there, but the water that's between the marbles. That's essentially kind of a stylized way of what we've got, how you explain groundwater to somebody. And what would a geology or groundwater talk be without the hydraulic cycle? So that hydrogeologic cycle, all the rain falls on the plains or the hills and runs off or soaks in, makes its way towards the lower part via gravity or pressure, goes to a stream or goes to the groundwater. Shallow groundwater may go to the stream or may not be connected. The deep groundwater may completely bypass the stream or the creek. So it's just, everybody's seen that. But you can't have a groundwater talk without talking about this. It's all one big integrated system. And you're saying, whoa, wait, I thought this was a groundwater talk. Platte River is groundwater in a lot of cases. I mean, essentially. But let's see what I'm talking about here. The Platte River Basin covers a good part of Nebraska, more than half, and a lot of Wyoming and Colorado. And the recharge, or the water for the Platte River, comes from the mountains, the snow and the rainfall that happens. The big flood in September last year around Boulder was up in here, went down the South Platte, and went all the way over to the middle part of the state. I've got an angle here that I can't see all the way around, but all the way almost to Doniphan. I think they saw the effects of the flood. That's a long ways. But the Platte River Valley at that time was also soaking up a lot of that flood water. It's all one big integrated system. And the state is trying to manage that. Department of Natural Resources and the NRDs are trying to manage that water as one integrated system. They're getting into that. Now what I've done here is just real kind of basic. I've cut off the High Plains Aquifer just on the Nebraska boundaries, just cropped the picture a little bit. And I'm going to show the Platte River Valley on top of it. So, whoops, I wanted to go this way. There it is without it. There it is with it. You can see where a lot of that recharge is coming from, that they're connected. The flow from many of the loop rivers is almost entirely groundwater based. But they do cover, they kind of help each other out. There's groundwater and there's surface water and there's flow in some of these streams because of groundwater. And with that, you saw a little glimpse of that. I have a picture of an artesian well on the near the edge of the north branch of the Middle Loop River. And we got that because we send people out every summer to doing sampling. We hire about 7 to 8 temporaries in the summer, and they're college students, like many of you. And they go out and they sample surface water, they gather bugs and little critters and sometimes fish, and they do some laboratory analysis too, so they learn about, we do some in-house lab stuff with bacteria and some of the pesticides. And it's a good opportunity. You get good experience and teamwork, and they have a good time, but they work hard too. But this gal had not seen an artesian well before, and so they went up and paddled around it a little bit with their shoes and boots on, because it's probably about 50, 52 degrees. It's not the warmest thing in the world. Feels good on a hot day, though. Got a depth to water map for Nebraska. The really dark blue here is greater than 200 feet to depth of water, from the surface down to the top of the water table. The lightest blue parts, like in the Platte Valley here, is 50 feet or less depth of water. So here we've got the Platte Valley, and you can see again real shallow depth of water, sandy soils, and alluvial, sandy, gravelly aquifer. Makes it very much more, actually more vulnerable to contamination, to the threats of pollution that are out there. So that's one of the things, if you're going to put a vulnerability area together, the shallow depth of water and the sandy soils are going to be the ones that are going to be most vulnerable. Lots of wells. I think we talked a little bit about, kind of alluded to that with our amount of irrigated acres that are irrigated by groundwater. But this map shows 171,000 plus registered wells. Now, if you've grown up in Nebraska, you think, oh, so what? Well, you go to some states and they might have 10,000 wells, and they may not even register their wells. We have a lot of great data and a lot of good ways of analyzing it, and there's a lot of good information usually associated with the registered well that Department of Natural Resources has online. But this just shows this is just registered water wells. And even before 1993, domestic wells were not required to be registered. So we have a whole bunch of private farm wells that aren't necessarily in this database. So I mentioned this a little bit earlier. One of the big threats to groundwater is nitrates. Now, I'm not saying that's the only threat. What I am saying is it seems to be the most pervasive and the most widespread threat to groundwater quality in the state. Other threats, of course, there's natural uranium and natural selenium. That's getting into some of the drinking water supplies. We have volatile organic compounds from industry, degreasers, for example, from an automobile shop. Those can get into groundwater as well. Gasoline from leaking underground storage tanks. Anything that happens at a factory, there's a potential for something to spill, get into the groundwater. The RCRA and Superfund programs at Department of Environmental Quality do a lot of cleanups for that. But the biggest threat, I think, the biggest, most pervasive, most widespread threat to groundwater quality is nitrates. Now, what do we got going on with that? Well, the Federal Safe Drinking Water Act and Nebraska regulations that kind of mirror that put the maximum contaminant level for drinking water at 10 parts per million or 10 milligrams per liter. Now, and again, just as in public water supply stuff, that's the number that is set for drinking water supplies from a public community water system, well, any kind of water system. But one that towns and SIDs and rural water districts use to distribute water to people, that MCL, maximum contaminant level, is 10 parts per million. If you have a private well, your own well at a rural residence, you're not hooked up to a city, you're not paying a water bill, you're just paying electricity for that private drinking water well, you don't have that regulation. It's up to you to manage and know what those nitrates might be, especially if you have small children or pregnant women, or even small baby animals like baby calves and baby pigs are susceptible to nitrate too. But it's just like no one comes and tells you when it's time to change or put a new set of shingles on your roof. No one's going to come and tell you that you need to get your water tested and it may or may not be safe. So it's up to the private well owner to know what their nitrates are and see whether they feel it's safe or not. And there's a lot of help out there for that. University Extension, the Natural Resources Districts. We can give advice from DEQ, and so will Health and Human Services. But there aren't any regulations that really tie down that 10 parts per million for the private drinking water well. What are the health risks from nitrates? Well, I mentioned babies and pregnant women because there's the blue baby syndrome, and I'm not going to try and say that. I never get it right. I think Dan Snow probably is the only one for sure in the room that I know of that would be able to say that word. But it has to do with the baby's guts, stomach, and intestines not having the proper bacteria developed internally that we all have as grown-ups that allows them to process nitrate and nitrite in the water that they're drinking, whether it's through formula or regular water, or even breast milk. And it causes the blood not to be able to carry enough oxygen. Therefore, that's why it's called blue baby. And there are some links to gastric problems, possibly cancer. I don't have actual literature on that. I'm sure it's out there, but just EPA has not officially recognized that as an actual threat. So I just put it down as something to be aware of. This is probably my favoriteest map in the entire world. It's made up of 25,000 analyses, the most recent analyses from the Ag Chemical Clearinghouse, where lots and lots of data is stored. Matter of fact, in that Ag Chemical Clearinghouse database, there's over 450,000 entries in it. That's not all nitrates, but there are a lot of nitrate values in that. For instance, and why I say the most recent nitrate concentration in a well, if a well out here had been sampled 10 times, we're going to use the most current one for this map. The green little dots are less than 7.5, and then you got your red areas, red dots, where it's over 20 parts per million. And remember that the MCL is 10. Well, why do we see it in those areas? Well, we talked a little bit about that already. Shallow depth of water, sandy soils, lots of irrigation, lots of opportunity for farm chemicals, including nitrogen fertilizer, to make it down into groundwater. Very easy. We also see that up in the northern Holt County and some of those areas along the Elkhorn. And out here on the south, really limited area on the South Platte Valley, right in the aquifer along the South Platte. Surprisingly, though, down here in southeast Nebraska, there's also a lot of red dots. And why is that? Well, it's certainly not shallow depth of water, and it's certainly not sandy soils. It's very clay soils. The glaciers have been across that at one point in the past. And it's certainly not seemingly to be as vulnerable as like the Platte Valley. Well, the first part of the state that was settled was the southeast part of the state. So we're talking about when people needed water, they would dig a well. And usually I hate that term. I don't like the term digging a well, because you ought to be drilling a well. That's the proper way of doing it. But they actually did. They dug wells when they first settled Nebraska. And so they're large diameter wells. They're 2 to 4, 6 feet diameter circles that are brick lined or stone lined. And that's where they got their water from. Water would seep in on the bottom, and they'd put a bucket down. Well, guess what else can happen? Anything can roll off the surface down into that well. Anything can fall in there and die. Mice, snakes, gophers, you got it. So even though there's been a lot of efforts to close those wells and to drill proper wells, the legacy of those hand-dug wells still exists. The water, in many cases, had gotten contaminated by activities that were going on 100, 150 years ago. And it just takes a long time for that kind of thing to get cleared up, if it ever can. So you got some odd things going on. You got your sandy soils, your shallow depth of water, and then you have old well construction. And maybe some in this area is just a lot of use of the groundwater and a lot of irrigation wells that don't have as good of construction as we'd like right now, but allowing things to seep down along the casing or something. Any one of these topics we could spend the whole hour talking about. So I'm giving you pretty much a big overflight view of something that's under the ground, as Daryl Peterson was pointing out. But it's there. We're working on it. This is kind of some statistics we ran on this same database, the Ag Chemical Clearinghouse. Since about 1994, we've had at least around 3,000 or more samples taken in the database. So we figured that was a good date to start doing some analysis of. Each bar is the number of samples per year. So here, there's almost 4,000 in 1994. The line with the diamonds on it is the median, which of course means half above, half below that number. And then the line is a trend line. So we did kind of a trend line, and it looks like it is certainly going up, but it isn't going up that much. I think over here it's around 5 parts per million, milligrams per liter, and then the median trend over here is more like 5.5 or so. So over the last almost 20 years, It's gone up a little bit, the median, but maybe not a whole lot. With this, I'm kind of hopeful. I'm hopeful that there actually is a lot of good groundwater quality still in the state. One of the things too, with a big database like this, the NRDs are doing a lot of this sampling. When they find a problem area, they're probably going back to that problem area and sampling more. So is this skewed a little bit to an areas that have more problems? It probably is. But there's a lot of data in it too. So when you get a lot of data, it tends to help self-correct in some ways. But we've got to keep that in mind. Are we seeing a lot of analyses over the years? They've gone back to the same well. Well, that map let's see, wrong way there. The map is the most recent. So that isn't multiplying the effect of going back to a well. But wrong direction again. There we go. The graph is all of the data. So we got over 80,000 analyses in this graph being looked at. And what's happening on the public water supply side of things? Well, of course, I think Health and Human Services requires towns to sample at least once every 3 years for nitrate. But if their samples come up, and it might be every year, I'm not absolutely sure about that because I'm not Health and Human Services, but if the samples come up over 5.5 routinely, 5.5 parts per million routinely, then they are required to sample quarterly. So they keep sampling quarterly unless the trend starts coming down below 5.5 parts per million. So you got 66 communities out of our, what do we say, about 530 or so. So what happens if they keep on going up? Well, if you get above 10 or 10.5 usually, then the Health and Human Services is going to issue an administrative order to that town. Right now there are 9 communities. If you start counting dots, because you're going to check me on my counting, this one down here is actually 2 dots pretty much on top of each other. It's Richardson County and Richardson County Rural Water District number 1 and Humboldt. They're 2 miles apart as far as where their wells are. We're trying to get them to combine systems, but it's small town politics. You know what that, I don't know if you know what that's like. It's not that great. But these are the towns that have to come up with some sort of solution, and they're given a time frame. Health and Human Services gives them a time frame to come up with their solution. The solution is generally one of a couple things. Drill a new well. Can you go out a few miles some other direction from town or from the current wells and find some better groundwater? You know, you'll knock on wood, hope it's better groundwater. They do a lot of test drilling, looking for better groundwater sometimes. Another option number 2, actually hook onto another system. Is there somebody close by that's got a good source of water that you can put a pipeline to? They have enough capacity, water quality's okay, and it isn't so far that you're going to spend too much money on pipe. Can you buy from that system? Are they a willing seller and all that? And then the third, least desirable option for these towns is treatment. Treatment is hugely expensive. Not only the upfront treatment plant, because we're probably talking about $300,000, $400,000, $500,000 just for a treatment plant. Ongoing operation and maintenance is very expensive. The electricity to run the well is very expensive. You usually have a lot of wastewater that you can't use when you have to do a treatment system. So that's the least desirable. Sometimes towns are forced into it. Who all has treatment systems in Nebraska? We got 12 communities that have treatment systems for nitrate in Nebraska. Some of them, and I know there's more than just these 3, but McCook, Benkelman, and I think that's Baird, not only treat for nitrates, but they treat for uranium too. We're seeing a lot more uranium in drinking water than we used to. So they're spending a lot of money. Seward has treatment plant put in within the last few years, and they spent somewhere like, I don't know if it was $4 or $8 million. It's a lot of millions. That's really what counts. Is a lot of millions of dollars was spent just to develop the treatment plant. Because they're on the bigger side. And on your list of lectures coming up towards the end of the semester, Marty is talking from the city of Hastings. He's got a great story because they're getting ready. They've got nitrate and uranium problems, and they're the biggest city that's faced with that right now in Nebraska. So it's a really good talk. I've heard it. So make sure you come to that one and listen to it. It's really good. What's going on? What's being done? Well, I say that with a map of the NRDs in bright colors because that's what the solution is that's happening right now. The 23 natural resources districts were developed, actually began in 1972 legislation was in the late 60s. It took them a few years to get organized, and they were put in place. In an unusual manner, they have taxing authority. Other states have things that are kind of like natural resources districts. Nobody's exactly like this, but nobody else has taxing authority. The board of directors is locally elected, and it's up to them to manage and set the rules and how they're going to prioritize, and they're dealing with all these quantity issues, and they have always dealt with quality issues too for groundwater. They also plant trees, and they stop erosion, and they do things like that too. They're a good resource locally. Their authority comes from the Groundwater Management Protection Act. DEQ also has a regulation that authority comes from the Groundwater Management Protection Act. All but 2 of the NRDs have a groundwater management area that's developed for quality, for groundwater quality. And that groundwater quality authority is just the non-point source, not point sources, not factories discharging or spills or lagoons or something like that, but it is non-point source, the widespread use of fertilizer and things like that that cause a widespread non-specific pollution that happens, that shows up in the groundwater. Typical best management practices that the NRDs are allowed by law to enforce and require. Farm operator, so the farmers are required to be certified and have ongoing education. Annual reporting, and what do they report? Well, they report the results of their soil sampling and their water sampling. The soil sampling, the nitrogen content of the soil and the nitrogen content of the irrigation water. And they're supposed to use those results in a calculation to determine next year's fertilizer rate. So, do you need to put on 50 more pounds per acre? Are you going to get more yield, or do you have to hold back? I mean, that's all in that calculation. The amount of water, irrigation water management, actually is just as important as the amount of fertilizer you're putting on. That may sound counterintuitive, but you put a lot of water on, it's going to drag that nitrogen through the crop zone before the root zone, before the crops actually have a chance to use it, and it's going to get down to groundwater a lot faster. So irrigation water management, the amount of water going on, is very important, not only for our potential drought issues, but the actual management of nitrogen input to the groundwater. One of the best, I think, and easiest BMPs that is allowed or is required is prohibition of fall or winter fertilization. They're not allowing farmers to go out and put on fertilizer on the fields until it's springtime and it's closer to the time when the corn or the beans will actually use that fertilizer. Has it done any good? Well, the Central Platte's been doing this kind of work for quite a few years. Remember, the NRD started in 1972. Well, in the late 80s, the NRD put in a groundwater management area that's specific for quality. And the white areas, I hope you can see this okay, the white areas are just phase 1. Usually NRDs have their management areas separated out into phases. The higher number, the more requirements, the more required BMPs. The blue is phase 2, and the pinky purpley color here is phase 3, where the most requirements are usually imposed. So they've been doing that since about 1988, and here are nitrate results averaged across the whole district. Maybe kind of fluffy data, but it's what they put out. And it was pretty high then, and gradually I think it's been going down. A lot of Central Platte is that sandy soils and shallow depth of water, so it's going to get impacted. It's the most vulnerable. Things are going to happen to it fast. Well, on the reverse side, hopefully, things are going to clean up a little bit faster too, and we see a little bit of that maybe happening here. It's not fast, and remember what the MCL is. It's 10, so the average for the district is still quite a bit above 10. But it's what it is, and they're working on it to make it better. They have a lot of requirements in place, and people have been pretty good. There aren't too many enforcement actions. The farmers have really been usually going along with this. Just about wrapping up here. Here's my resources. Hopefully you'll get a chance. These slides will be available or something. These were some of the resources that I gave at the readings to Martha and Pat beforehand. One of my staff, Ryan Chapman, really helped out a lot in developing all these maps and stuff. He's our wellhead protection coordinator. He helps towns try and work with voluntary protection activities to protect their drinking water wells. And if you have any questions about, sometimes have jobs available, not all the time, and some are temporary job opportunities. Just give me a call or write me an email. I'll get back to you or refer your question to somebody who has that knowledge. And with that, the obligatory sunset picture taken during the drought in June 2012 in northeast Buffalo County. What questions we got? We have a microphone that Martha's going to haul around to people if somebody has questions.
Recorded seminars, so to get the recording of the questions, we'll need the microphone.
I was wondering about how groundwater and surface water are, related. If any of these sources of contamination have been traced into surface waters like the Platte, and also if you have any idea about how these sources of groundwater contamination might impact something like the Platte River Recovery and Implementation Program for endangered species.
Good. They do interact. I mean, the Platte River and the groundwater are intricately tied together. I always say if you dig a post hole out in the Platte Valley, up comes water. Well, you've just hit groundwater. It's very intimately involved with each other. Now, as far as quality, one of your questions was, will quality impact the recovery program that they're doing for the fish and wildlife stuff, one of the compacts and one of the agreements that are in place that is going on right now. Groundwater quality is, in the Platte Valley, is anywhere from 2, which is background, generally 2 to 3 parts per million, to maybe, 20, 30 or so. But the Platte River, in general, is pretty low as far as what we consider low drinking water standards, so like maybe 1 part per million coming through. And it seems to have enough velocity and volume to it that it pretty much goes through, and so it doesn't usually pick up too much nitrate from the groundwater. In many cases, the surface water from the Platte River recharges the groundwater and causes a nice barrier. It causes its own a better water quality and keeps the higher nitrate groundwater away from the Platte River, really, because there's so much water, even in dry years, there's so much more water in the Platte Valley alluvium. And it doesn't really impact they interact, but only to a point. So, was there something else? Or does that pretty much cover it? That pretty much covers it? Okay. There's one way down there. Yeah, you should have not let her run clear over to the other side.
I just wondered if the recent event in West Virginia has caused any additional actions here in Nebraska as far as water safety.
Good question, because we just talked about that yesterday. With the legislature in session right now, we're always concerned that one of them is going to say, well, what's the state doing to protect against large chemical storage or something like that? Now, you all know what we're talking about. Charleston, West Virginia, until just like yesterday and today, wasn't allowed to use their public water supply water because it had been contaminated by coal handling chemicals. I believe that's right. A spill got into a lake, which was a drinking water source for many, many people. Now, what do we have in place? We're not too far off from West Virginia. I mean, in actuality, we don't have much more in place than they would. It's caused us to think about that quite a bit and kind of make a list, at least written down on a whiteboard, of who is out there. State Farm Marshal does some above ground storage, tank inspections and certifications, but mostly at the beginning of when they're when somebody's planning a new chemical storage. There are some regs for ag chemical storage, like fertilizer and pesticides. That's with our agency, but it's more of a authorized by rule. So here's the rule. You follow the rules, you're set. But it does have engineer requirements for putting secondary containment around large tanks, and even the loadout facilities when they're loading chemicals off of trains or something, or big tanks, the smaller tanks, they have to have loadout secondary containment, and even the guys who are out there flying, spraying, aerial spraying of pesticides have to have loadout facilities. So we have that going for us. We have a pretty good emergency response team, but that's after the fact. You know, we would rather be preventative. And I think that we're basically not too far off from what West Virginia has, and it's something that we're thinking a lot about right now. So it was a wake-up call to many states, including us.
It was easy for contamination in the Platte River Valley, and that's likely why you have the high nitrates. But is it not also true that in areas where the water table is deeper, the soils have lower permeabilities, that you likely have nitrate en route to the water table?
We do. Those deeper groundwater and the ones that even with the silty clays or clay-type soils, it's just tying up much more in the soil, and we may have something coming down the road that we're just in no way ready for. And if it's taking 40 or 50 years to make it there, then it's going to be quite a while before even if we stopped irrigating and stopped farming right now, we wouldn't get rid of it for another 50 years. Sometimes I think EPA doesn't get that. I mean, I said to an EPA guy once, he said, even if we'd completely move out of the state, have no people here, no farming, no irrigation, nothing, it would still be a really long time before we'd even see easy things, well, relatively easy things to clean up, like lakes. They are not going to recover very quickly. So you're right. Even in the deeper waters and the tighter soils, we see contamination showing up now, and it's building up in the soils. Nitrates love to attach to clay.
What is the DEQ standing on atrazine contamination in the groundwater?
Atrazine contamination in groundwater? Is that what you asked? Well, it happens. I think it's one of those things that if you look for it, you would find it. It's an expensive test, and we don't run it very much. The NRDs have a responsibility to non-point source pollution, and they are doing some limited monitoring of atrazine. I think a lot of the atrazine that we have found is because of maybe well construction issues and runoff from a field going down the casing through gopher holes or poor construction or something like that. But there is some non-point source atrazine pollution going on. On the other hand, if atrazine just sits out in the sunshine for a little bit, it breaks down pretty quickly. So if there's even a little bit of a delay, then it's going to help it naturally degrade some. Once it gets into water, though, it pretty much likes to hang out with the water, and we see a lot of atrazine, for example, in the Big Blue Basin, going down the Big Blue River and getting into Tuttle Creek Reservoir, which is the water source for Manhattan, Kansas. And that's kind of a big issue for them, too. So there is some of it. We don't have a good handle on it, and it's out there.
A follow-up on the atrazine, Jim Carr did a lot of study on the atrazine in groundwater and that. And he found that it was degraded, but it degraded to daughter products that were not that much different
Right.
from the atrazine itself, and that's not tested for most of the time.
Right. That isn't usually tested for. I think when you do a trizine kit, though, when you just do the kit stuff, you'll pick up those daughter products too. But a lot of our stuff is sent off to a lab, and it's an expensive lab, especially compared to nitrates. And you're just testing for atrazine and not the daughter products specifically. That might be it. Everybody's anxious to go home. It's about that time.